The solar system does not end with Neptune. It unravels. Beyond the last giant planet, the map stops feeling neat. The sunlight weakens, time stretches, and the strangest worlds in our system begin. Out there, one small distant body takes more than 11,000 years to circle the sun just once. That is where we begin tonight, not in the warm, familiar regions, but at the quiet edge, where the solar system becomes colder, darker, older feeling, and far more mysterious than most people realize. This is gentle science, hidden worlds and strange science, told softly for sleep. And tonight, we travel beyond Neptune, to Pluto, to Eris, to Sedna, and to the scattered kingdom of distant worlds around them. If you move outward from the sun, the early structure feels easy to understand. Mercury, Venus, Earth, Mars. Then the giant planets, Jupiter, Saturn, Uranus, Neptune. It feels orderly, inner worlds, outer giants, and then an ending. But nature is rarely that tidy, because Neptune is not a wall. It is not the final border. It is only the place where the familiar version of the solar system begins to fade. Beyond it, the structure loosens. The sunlight drops. The temperatures fall. The objects become smaller, slower, stranger. And the whole region starts to feel less like a finished planetary system and more like a cold archive. A place where ancient material remains. A place where old surfaces survive. A place where distance protects memory. That is one of the first scientific reasons this region matters so much. Many worlds beyond Neptune are not just far away. They may also be among the least changed objects in the solar system. Less heated, less reshaped, less disturbed. Which means the farther outward we go, the closer we sometimes come to the solar system's early memory. And yet this region is not empty at all. That is the first real surprise. People often talk as though the planets stop, and then space simply takes over. But beyond Neptune lies the Kuiper Belt, a vast region of icy bodies, dwarf planets, fragments, and remote worlds still only partly understood. Pluto is there, but Pluto is only the beginning. Eris is there, Haumea, Makemake. And far beyond even the main Kuiper Belt, there are stranger objects still. Sedna is one of the most haunting. Its orbit is so immense, so stretched, so detached, that it seems to belong half to the solar system and half to some deeper outer darkness. 1 year on Sedna lasts roughly 11,000 years. When Sedna completes a single orbit, entire human civilizations could rise, change, and disappear. That is not just distance, it is a different relationship to time. And that is the second surprise. The outer solar system is not only a different place, it is a different tempo. Closer worlds teach us motion in ways we can almost feel. Days, years, seasons. But beyond Neptune, time thins out. A sunrise can still happen, but the year behind it is enormous. The sun still shines, but from so far away, it no longer rules the landscape in the way it rules Earth. Out there, sunlight does not vanish, but it loses authority. That changes the feeling of a world. On Earth, the sun organizes everything: warmth, weather, rhythm. Beyond Neptune, the sun is still present, but it has become emotionally distant, still bright in physics, but no longer near in feeling. That is what makes these distant objects so strange. They are not rogue worlds. They still belong to the sun, but they belong at such a distance that the relationship begins to feel abstract, as if the solar system itself is stretching thin, as if the old centered map is giving way to something wider, colder, and less orderly. That is why worlds beyond Neptune fit this channel so perfectly, because this is exactly where hidden worlds begin to outnumber familiar ones. exactly where science becomes quieter and stranger, exactly where the solar system stops feeling close and starts feeling deep. And the deeper we go, the more unusual the map becomes. Some of these objects move in relatively flat paths, as though they still remember the original disk from which the planets formed. Others travel on tilted or stretched orbits, as though something disturbed them long ago. Some may be relics of migration, some the survivors of collisions, some the preserved leftovers of the earliest solar system. And Pluto, perhaps the most famous of them, already shows how strange this outer region can be. Mountains of water ice, glaciers of nitrogen, a faint blue haze, a real world, and still only one member of a much larger and stranger outer family. That is the feeling we want to keep tonight. Every time the edge of the solar system seems empty, it becomes more populated. Every time it seems simple, it becomes more layered. Every time it feels like the end, it turns out to be the beginning of another colder and quieter zone. So before we go deeper, pause for a moment. The last giant planet is behind you. The sun is smaller now. The warmth is almost gone. And ahead of you is a scattered field of icy worlds, some known, many unknown, all moving in immense silence. That is where we are now, at the point where the solar system stops feeling familiar and becomes a kingdom of distant ice. In the next part, we will enter that kingdom properly. We will begin with Pluto and the dwarf planets. We will ask what kind of worlds they really are, why Eris helped change the definition of a planet, and why the outer solar system turned out to be far richer and far stranger than the old maps ever suggested. Pluto was supposed to be the 9th planet. Instead, it became the first clear sign that the old map of the solar system was too simple. That is where part 2 begins. Not with emptiness, but with a mistake. A useful mistake. A beautiful mistake. The kind that forces science to grow. For a long time, Pluto stood alone in the imagination. A small, distant world, cold, dim, mysterious. The last planet. The final marker before space simply became too dark and too wide to matter. And for decades, that idea felt complete. Children learned the list. Mercury to Pluto. The solar system seemed to end in one tiny frozen object, a strange and lonely full stop. But Pluto was never really a full stop. It was the first hint that the outer solar system was not a line ending in a single world. It was a doorway into a region crowded with distant bodies, icy survivors, partial worlds, and categories our old language was not built to handle. That is the first thing to understand tonight. Pluto did not become less interesting when it stopped being called the 9th planet. It became more interesting, because now it was no longer the last easy answer. Now it was the first member of a larger, stranger family. And Pluto itself turned out to be astonishing. For many years, Pluto was only a point of light, too far away to reveal much of anything. People imagined a small, frozen ball, perhaps uniform, perhaps inactive, perhaps just a dim leftover at the edge of the sun's reach. Then the pictures arrived, and the point of light became a real place, a world with plains, mountains, layers of haze, and a surface made not of one simple material, but of different ices behaving in different ways. That alone is one of the most delightful facts in the outer solar system. On Pluto, water ice behaves almost like bedrock. At those temperatures, water ice is so hard, so rigid, that mountains can be built from it. Imagine that for a moment. On Earth, ice suggests fragility, melting, winter. On Pluto, ice can become architecture. Not snow drifting off a roof, but massive ranges rising against a dark horizon. Real mountains, made of frozen water. And around them, other ices move more easily. Nitrogen ice, for example, can creep and flow across the surface. So Pluto is not just a distant cold rock. It is a place where the familiar materials of Earth, water, ice, frost, behave by alien rules. That is what makes it feel so alive in the imagination. Not alive in the biological sense, alive in the planetary sense. A world with texture, with contrast, with active processes, with a visible personality. And perhaps no feature captures that feeling better than the great bright plane we now call Sputnik Planitia, the heart of Pluto, or at least the left half of the famous heart-shaped region that made so many people pause when the first clear images appeared. It is almost impossible not to feel something when you see it. A pale, smooth basin on a dark world, far beyond Neptune, a shape so familiar on a place so remote. But Sputnik Planitia is not just visually memorable, it is scientifically strange. A vast basin filled largely with nitrogen ice, smooth in some regions, cellular in others, showing signs that the surface there may slowly overturn and renew itself over time. Not quickly, not violently, but enough to remind us that even this far out, a world can still change. That is a powerful correction to the old inner solar system instinct. Distance does not always mean dead. Cold does not always mean finished. A world can be unimaginably remote and still possess geology, still possess atmosphere, still possess internal stories. Pluto even has a sky. Thin, yes. Fragile, yes. But real. A blue haze, layered and delicate, hanging above a world where the sun is only a distant hard light. That image still feels almost impossible. A blue sky component, at the edge of the solar system. Not because Pluto is Earth-like, it is not, but because planetary reality keeps refusing to stay simple. Every time we think distance will reduce a world to almost nothing, the world answers back with texture, with process, with detail. That is why Pluto matters. Not because of nostalgia, not because it was once number 9, but because it teaches a deeper lesson. The solar system becomes stranger, not emptier, as you move outward. And Pluto is only one world. Charon makes the story even better, because Pluto is not drifting through the outer darkness alone. It has moons, and one of them, Charon, is so large relative to Pluto that the two objects orbit a point in space that lies outside Pluto itself. This is one of the most elegant scientific hooks in the whole region. Pluto and Charon are not just planet and moon in the ordinary emotional sense. They are almost a double world, a paired system, two bodies locked together, showing each other the same face, turning in a slow, cold dance around a shared center that hangs in empty space between them. That is extraordinary. It means the outer solar system does not merely give us small leftovers. It gives us arrangements, relationships, architectures that feel different from the familiar models closer to the sun. And Charon is not a trivial companion. It is a real landscape, dark at the pole, cut by great fractures and canyons, marked by a geological past of its own. So even one so-called dwarf planet turns out not to be one object, but a whole system, a small, distant kingdom. And once Pluto looked like that, science could no longer pretend it was alone. Because if one strange world existed there, why not others? That question matters. It is one of the quiet engines of this whole story. The more carefully astronomers looked beyond Neptune, the more objects they found. Not one lonely edge marker, many bodies, many orbits, many worlds in between categories. That is where Eris enters, and Eris changed everything. In some ways, Eris is the most important distant object after Pluto, not because it is warmer, or prettier, or easier to imagine, but because it forced astronomy into a difficult question. If Pluto is a planet, and Eris is there too, then what exactly do we mean by planet? That sounds like a linguistic problem. But it is not only that. It is a map problem, a category problem, a question about how nature actually organizes itself. Eris is slightly smaller in diameter than Pluto, but more massive, darker in tone, farther out, colder, a true outer world. And when it was found, it created a kind of pressure on the old system of naming. Because if Pluto stayed a planet, then Eris seemed to qualify as well. And if Eris qualified, then other large distant objects might have to join the list too. The neat classroom map would not stay neat for long. The number of planets might keep expanding. 9, then 10, then more. That does not sound disastrous. In fact, it sounds a little exciting. But scientifically, it exposed a deeper issue. The word planet had been carrying more certainty than the solar system itself was willing to support. The old list felt stable because the discoveries had not yet caught up with the reality. Once they did, the category had to be examined. So in 2006, astronomers formalized a definition. A planet would orbit the Sun, be massive enough for its gravity to pull itself into a rounded shape, and clear its orbital neighborhood. That last part changed Pluto's status. Pluto is round, it orbits the Sun, but it shares its region with many other Kuiper Belt objects. It has not cleared the zone around its orbit in the way the major planets have. So Pluto became a dwarf planet. And yes, people reacted emotionally, because categories are never just scientific, they are also personal. Many people loved Pluto as the 9th planet. It felt like a small, distant underdog, a lonely world at the edge. To lose that title seemed, for some, like losing the world itself. But nothing was lost scientifically. Pluto did not shrink. Its mountains remained. Its nitrogen plains remained. Its blue haze remained. Its double world dance with Charon remained. Only our map changed, and maps are allowed to improve. That is the real emotional maturity of this region. Beyond Neptune, the solar system asks us to trade a simpler picture for a truer one, and the truer one is richer. Because once Pluto stopped being the exception, it became part of a landscape that includes Eris, and Haumea, and Makemake, each of them strange in a different way. Haumea may be the most physically unusual of the group. It spins so fast, in less than 4 hours, that it is stretched into a long ellipsoidal shape. Not a neat sphere, not a calm, rounded world, but something more like a rapidly turning cosmic stone, smoothed into an elongated form by its own rotation. It also appears to be associated with a collisional family, fragments that may share a common origin in some ancient impact. So here again, the outer solar system refuses to give us one tidy kind of object. Instead, it gives us a fast-spinning, stretched dwarf planet, with its own moons, its own history of violence, its own identity. Makemake is different again. Brighter than charcoal-dark outer objects, rich in methane ice at the surface, cold and reddish. A world that feels quiet even by the standards of this region. Not as famous as Pluto, not as disruptive as Eris, but part of the same growing truth. The edge of the solar system is populated by real worlds. Not all identical, not all equally large, not all easily classified, but real nonetheless. That word matters tonight. Worlds, because one of the easiest mistakes in astronomy, especially at great distance, is to let objects become too abstract, to think of them as data points, dots, orbital solutions. But beyond Neptune, the dots keep turning back into places with gravity, with surfaces, with histories, with specific weirdness. A world where water ice is mountain rock, a world with a shared orbital center hanging outside itself, a world whose discovery forced the definition of planet to be rewritten, a world spun into a stretched shape by its own speed, a world glazed in methane frost under distant sunlight, and perhaps many more still waiting. This is why I do not think of the outer solar system as the attic of the planetary system. That metaphor is too passive, too still, too full of forgotten storage. The region beyond Neptune is not just where leftovers go, it is where the solar system reveals how incomplete our first impressions were. We thought the system ended neatly, It did not. We thought Pluto was alone. It was not. We thought distance would simplify everything. It did the opposite. The farther we looked, the more categories blurred. Planet, dwarf planet, moon, double world, Kuiper belt object. These are useful terms, but nature seems less interested in sharp lines than we are. It prefers gradients, families, transitions, and that is why this region feels so intellectually satisfying. It does not merely add new objects, it changes the way we think about classification itself. Closer to the Sun, the structure feels strong enough that names seem easy. Planet, moon, asteroid. But beyond Neptune, things begin to slip between those old compartments. Not because science is failing, but because reality is larger than the first draft of the diagram. That is exactly the kind of strangeness this channel should love. Not random weirdness, layered weirdness, the kind that becomes more meaningful the longer you stay with it. And there is another reason these worlds matter. They help connect the visible present of the solar system to its early history. Because many of these distant objects have preserved material, surface chemistry, and orbital clues that speak quietly about formation, migration, collision, and survival. The outer solar system is not merely a distant collection, it is also evidence, a record kept in cold storage. The sun's old memory, spread across icy worlds. That is why Pluto and Eris are not just nice curiosities. They are part of the archive, part of the evidence that the solar system once moved through a more chaotic youth, that giant planets migrated, that smaller bodies were scattered, that the map we know now was not always the map that existed. And this naturally leads to the next question. If Pluto and the dwarf planets already changed the old edge of the solar system so completely, then what happens when we go even farther, beyond the main Kuiper belt, beyond the more crowded family of known icy worlds, into the zone of detached objects, stretched orbits, and bodies like Sedna, that seem to move at the edge of belonging itself? That is where the outer darkness becomes even more psychologically strange. Because Pluto still feels like part of the neighborhood, Eris still feels like part of an extended family. But Sedna, and worlds like it, begin to feel as though the solar system is dissolving into deep time and distance. In the next part, we go there. Beyond the dwarf planets most people have heard of, beyond the better-known edge, into the slowest orbits, the most detached worlds, and the strange region where a single year can outlast recorded human history. If Pluto feels like the edge of the neighborhood, Sedna feels like the beginning of something else. Not another ordinary outer world, not simply a colder member of the same family, but a body so distant, so slow, and so strangely detached that it changes the emotional shape of the solar system. This is where the map starts to feel uncertain. Because beyond the main crowd of the Kuiper belt, beyond the region where Pluto and many other icy bodies still seem to belong to a broad shared structure, there are objects whose orbits are stretched so far and separated so deeply that they no longer feel like they live in the same outer landscape. They feel removed, not lost exactly, but less held, less governed by the familiar order we use to imagine the sun's domain. Sedna is the clearest example, and perhaps the most haunting. Its orbit is enormous, so enormous, it travels far beyond the main Kuiper belt, far beyond Pluto, far beyond what most people mean when they casually say, the edge of the solar system. And one full orbit takes roughly 11,000 years. That number is worth stopping for. Not because it is merely large, but because it changes the scale of thought itself. If Sedna completed a single year, human history as we usually tell it would fit inside only a part of that journey. Empires would rise, languages would split and disappear, religions would spread, cities would be founded and erased. And still, Sedna would not yet be back where it started. That is not just an orbit. It is a kind of deep time breathing, a motion so slow that the solar system begins to feel less like a set of planets and more like a layered archive of different clocks. Earth keeps one rhythm, Jupiter another, Pluto another still. And Sedna moves on a timescale that does not feel planetary in the ordinary human sense at all. It feels geological, civilizational, almost mythic. That is the first scientific and emotional hook of this region. The farther outward we go, the more the solar system stops being a single tempo and becomes a hierarchy of times. Some fast, some slow, some so slow they begin to detach from any intuitive idea of a year. This is one of the reasons the distant, detached objects matter so much. They do not only add more bodies to the map, they add new kinds of time. And time, in astronomy, is often more revealing than distance alone. Because distance tells us where something is, but orbital time tells us what kind of world it is to live there, what kind of sky it experiences, what kind of season, what kind of waiting. Sedna's waiting is almost beyond ordinary feeling. Even when it is nearest the sunlight is weak. Even then, the sun would not dominate the sky the way it does on Earth. It would still be a remote, hard brilliance. Not warmth in any familiar sense. Not a great presence pouring energy into weather and oceans and daily life. Just a distant source. Still real. Still central in physics, but already emotionally far away. And then Sedna continues outward, farther, farther, into a region where the sun becomes less like a ruler and more like a memory. That is what makes Sedna feel so unusual. It still belongs to the sun. Its path is still gravitationally tied to our star, and yet its orbit is so stretched and so detached from the denser inner populations beyond Neptune that it feels almost like a messenger from another zone, a body from the threshold, a world moving at the edge of belonging. That phrase matters, the edge of belonging, because that may be the best emotional definition of the detached outer solar system, not objects that are fully outside, not objects that are fully inside, but objects whose relationship to the sun has become so diluted by distance that the old idea of a close-knit planetary family begins to dissolve. This is where the solar system stops feeling like a tidy household and starts feeling like a fading sphere of influence, a great soft gradient, a domain that thins rather than ends. That scientific idea is important. There may not be one single hard border where the solar system suddenly stops. Instead, there are transitions, zones, populations of objects, regions shaped by different histories. The Kuiper belt, the detached objects, the scattered disk, and farther out still, the hypothetical Oort cloud, a vast spherical reservoir of icy bodies thought to surround the solar system at enormous distances. If the Kuiper belt is a broad outer ring, the Oort cloud is something far stranger. Not a flat belt, but an immense shell, a deep, frozen swarm, distributed in all directions. A place so distant that some of its objects may sit nearly halfway to the nearest stars. That is an astonishing scientific hook. Some objects associated with our solar system, if the Oort cloud truly exists as expected, may lie so far away that the distance to them is no longer best felt in planetary terms, but in interstellar terms. That means our solar system may not simply taper off after Neptune. It may continue outward, in diluted form, for unimaginable spans. Not with major planets, not with bright, obvious worlds, but with old, icy bodies, moving through a darkness where the sun is little more than an unusually bright star among others. That possibility changes everything, because the moment the Oort cloud enters the imagination, the solar system ceases to feel compact. It ceases even to feel like something that has a simple outer wall. Instead, it becomes a layered territory of decreasing influence, an empire of cold, thinning slowly into the galaxy. Sedna is so powerful because it seems to point toward that idea. It is not usually described as an Oort cloud object proper, but it feels like a clue that there are worlds out there, or proto-worlds, or icy relics, whose lives take place in a region so remote that our usual outer planet language barely reaches them. This is why Sedna has such psychological force. Pluto still feels like a place you can talk about with ordinary planetary vocabulary. Mountains, glaciers, haze, day and night, Charon. But Sedna begins to shift the conversation. Suddenly the questions become stranger. Who shaped that orbit? Why is it so detached? Was it influenced by Neptune long ago? By a passing star? By the sun's birth cluster? By an unseen massive object in the deep outer system? This is where another kind of scientific hook appears. The detached objects are not merely scenic curiosities. They are clues, orbital clues, fragments of gravitational history preserved in motion. Their strange paths may tell us something about the early solar system that no inner planet can say so clearly. Perhaps the young sun formed among many nearby stars in a dense stellar nursery. If so, close stellar encounters may once have disturbed the outer populations of icy bodies. Perhaps giant planet migration scattered objects outward. Perhaps the deep outer architecture we see traces of now is a fossil record of the solar system's chaotic youth. Or perhaps, and this is where the imagination sharpens, there is still some missing influence out there. Some unseen mass, some distant body, some gravitational explanation not yet fully mapped. This is one reason the outer solar system so often gives rise to big questions. Not because it is vague, but because it preserves uncertainty in a scientifically beautiful way. Close to the sun, many structures are already well defined. Closer worlds have been imaged in detail, measured repeatedly, visited by spacecraft. But farther out, the evidence becomes quieter, smaller in signal, longer in timescale, more dependent on patience. That makes the region feel intellectually different, less like a solved map, more like a field of hints, a place where one unusual orbit, one faint moving point in darkness, can open an entire conversation about the architecture of the solar system. That is exactly what happened with the idea often nicknamed Planet 9. Not a confirmed planet, not something we can speak of as a known world, but a hypothesis, an attempt to explain certain patterns in the orbits of some distant objects. This is worth handling carefully, because it is not a settled fact, but it is a fascinating question. Could there be an unseen massive planet, far beyond Neptune, shaping the extreme outer solar system through gravity? Maybe, maybe not, and either answer is interesting. If such a world exists, then our map is still more incomplete than we realized. And if it does not, then the detached objects must be telling some other story, perhaps about stellar encounters, or the deep memory of early migration. Either way, the outer solar system remains active in the mind, not active through storms or eruptions, but through unanswered structure, through patterns still being interpreted, through silence that contains information. That is a form of strangeness this channel should keep returning to. The outer darkness is not empty of meaning. It is dense with implication. Sedna is especially powerful because it carries all of this at once. It is a real object, a real orbit, a real world of some kind. Reddish in color, cold, far away. And yet it also feels symbolic. It feels like the moment the solar system begins to become dreamlike. Not because the science weakens, but because the scale becomes harder to hold in ordinary consciousness. Imagine standing there, not physically perhaps, but imaginatively. Imagine a landscape receiving sunlight so weak that noon would feel more like an austere idea than a source of warmth. Imagine a year so long that nothing in human life offers a real analogy. Imagine an orbit that carries the world through a path so vast that much of its journey takes place in near solitude. That is not merely another frozen object. That is a different kind of planetary existence. And it is not only Sedna. There are other extreme trans-Neptunian objects, other detached or highly elongated orbits, other bodies living in stretched relationships with the Sun. Some are smaller, some less famous, but together they create a population with a very distinct psychological effect. They make the solar system feel less like a stack of well-behaved circles and more like a fading field of survivors. Some still clustered, some scattered, some nearly detached. The image changes from order to persistence. That is another reason this region matters scientifically. It may preserve evidence of filtering, of selection, of which objects remained, which were thrown outward, which were destabilized, which were captured by strange orbital histories. The extreme outer solar system may be a museum of paths, and museums of paths, in astronomy, are often more revealing than museums of surfaces, because surfaces show what a world is made of, but orbits show what happened to it. Sedna's orbit is not just a track, it is a memory written in motion, a clue that something in the early architecture of the solar system, or its stellar environment, or perhaps its still unseen outer population, was more complex than the simple schoolroom diagram ever suggested. This is where the map truly opens. Not because we suddenly know less, but because we begin to know the right mysteries. That is a wonderful moment in science, the moment when confusion matures into better questions, and the outer solar system is full of those moments. At first, it seems like an ending. Then Pluto makes it a new beginning. Then Eris changes the categories. Then Haumea changes the shapes. Then Sedna changes the scale of time. And soon, the whole solar system is no longer a tidy set of planets, but a layered history of migration, survival, detachment, and hidden architecture. That is why the detached outer worlds matter so deeply. They do not merely extend the map. They dissolve its false certainty. They teach us that the Sun's domain does not stop in one easy gesture. It fades, scatters, loosens, remembers. And far from being disappointing, that makes it far more beautiful. Because neat endings are easy to memorize, but gradients are what nature actually loves. Cold gradients, gravitational gradients, gradients of light, of time, of belonging. And perhaps that is the best way to feel the distant outer system, not as a final edge, but as a thinning of intimacy. The farther outward you go, the less the Sun feels like a nearby source. The more it feels like a distant reference point, still central, still binding, but no longer close. There is something almost human in that. Not because these worlds are like us, they are not, but because we understand what it means for influence to remain, while nearness is lost. That may be why the detached objects linger in the mind. They carry the idea of connection stretched almost to breaking. A world still orbiting the Sun, but at such distance that the relationship begins to feel spectral. A world still inside the solar system, but already half translated into the language of interstellar darkness. In the next part, we will turn from orbital mystery to physical experience. What would it actually feel like to stand on one of these distant worlds? What would the sky look like? How bright would the Sun really be? What would silence mean there? And how does a landscape change when it belongs to a region where time itself seems to freeze? Now we turn from the map to the experience. Not just where these worlds are, or how long they take to orbit, or what categories we place them in, but what it might actually feel like to stand there, on Pluto, on Eris, on Sedna, or on some unnamed icy body, far beyond Neptune. Because a distant world is not only an astronomical object, it is also a kind of weather of the mind, a different relationship to light, to silence, to motion, to time. And the first thing to understand is that these places are not dark in the simple way people imagine. They are not caves. They are not starless voids. They are landscapes under a real sun, but a sun changed by distance. At Pluto, sunlight takes about 5.5 hours to arrive from the sun. By the time it reaches that world, the familiar source of life and warmth has become something colder in feeling. Still bright, still physically the sun, but no longer dominant in the emotional way it is on Earth. That is the first strange sensation of the outer solar system. The sun is present, and yet somehow absent. You would not look up and see a warm, ruling disk filling the sky with daylight in the way Earth does. You would see a small, intense source, hard and remote, less like the sun of childhood, and more like a brilliant authority that has stepped very far back from the scene. That changes the meaning of a day. On Earth, day is immersive. Light surrounds you, fills the air, warms the ground, activates the world. Even in winter, even through cloud, the sun feels near enough to govern everything. But far beyond Neptune, day begins to thin. It still exists, but it feels austere, filtered through distance, as though the landscape has accepted sunlight without ever really depending on it. That is one reason Pluto is such an unforgettable place in the imagination, because it is not simply dark. It is dim in a very specific and beautiful way. A real world, with real terrain, receiving real sunlight, and yet living at the edge of illumination. Imagine standing there. The surface beneath you is rigid with cold. In some regions, the ground may be nitrogen ice. In others, methane frost. In others, water ice harder and stronger than ordinary intuition expects. Mountains rise. Plains spread outward. A horizon exists. The sky exists. And yet the whole scene feels as though daylight has been reduced to a distant permission. Not a gift, not abundance. Just enough light to reveal the place. Not enough to make it feel warm. This is one of the deepest psychological differences. On Earth, light and comfort are often tied together. In the outer solar system, light and comfort separate. You can have one without the other. And that makes the visual experience more severe, sharper, more disciplined. A landscape beyond Neptune would not glow with kindness. It would reveal itself with restraint. Shapes would matter. Texture would matter. Contrast would matter. The weak angle of sunlight across ice plains and fractured ridges might make everything feel carved, almost etched into existence. A world not softened by thick warmth, but defined by distance and cold. On Pluto, there is another surprise. A haze. A thin, layered atmospheric haze that can scatter light in delicate ways. This is astonishing because it refuses the old lazy picture of Pluto as merely a dead, frozen point. It has a sky structure, not a dense Earth sky, not a breathable one, not a weather-rich one, but a real atmospheric presence. A blue haze over a world at the edge of the solar system. That image still carries an almost impossible beauty. Blue, not because Pluto is Earth-like, but because planetary light keeps finding ways to be more subtle than we expect. And then there are the seasons. Even out there, even with the sun so distant, seasons can still become extreme. Pluto's axis is tilted so strongly that long periods of strange illumination and long darkness affect huge portions of the world. Not just a small polar fringe, but nearly the entire planet in one way or another. That means the outer solar system is not only cold, it is also rhythmically strange. A place where the geometry of light becomes more dramatic, even as the light itself weakens. Now imagine moving outward from Pluto, farther, toward Eris, or beyond. The sun grows smaller again. Its power over the eye remains, but its emotional presence continues to retreat. At some point, the sky begins to feel less like a daylight sky, and more like a darkness gently interrupted by one intense point. You still know the sun is there, but now the stars begin to feel stronger, more equal. The solar system itself feels less centered. This is not because gravity has disappeared. It has not. But because nearness has disappeared. And human beings feel nearness very strongly. We notice warmth, scale, apparent size. When all of those begin to fall away, a place changes character. Beyond Neptune. The sun is no longer a companion. It is a reference point. That may be the cleanest way to say it. A reference point. Still central to the mathematics, no longer central to the feeling. Sedna is perhaps the most haunting expression of that. NASA's own imagery and descriptions emphasize that from Sedna, the sun would appear less like the large, warm disk we know from Earth, and more like an extremely bright star. Think about how strange that is. To live on a world where the sun has crossed over, from environment to object, from overwhelming presence to piercing distance. Content reference index equals 3. If you stood on Sedna, assuming for imagination's sake that survival were possible, the sky would not feel like a normal planetary sky at all. It would feel almost transitional. Part solar system sky, part interstellar sky. The sun would still be yours in a technical sense, but not in an intimate one. And that changes silence too. Because silence is not only the absence of sound, it is also the absence of immediacy. Earth is rarely silent in a pure way. Wind moves, water moves, trees answer light, birds react to morning. Clouds and weather carry energy from the sun through the atmosphere and across the ground. Even stillness on Earth is full of active systems. Beyond Neptune, especially on the smaller and thinner atmosphere worlds, silence becomes more literal. Not absolute, perhaps, but more complete. You might hear the faint crunch of your own step across hard frost, the brittle settling of ice, perhaps the slow sigh of very thin winds over frozen plains. But there would be no rich atmospheric conversation, no leaves, no surf, no rain. Not the layered soundscape of a world constantly reheated from above. Only local sound, small sound, sound confined to what is immediately happening. Everything else would appear motionless, and even motion itself changes character. On Earth, movement often feels fast because the environment is full of energy. Water cycles rapidly, clouds build and dissolve. Vegetation changes. Light transforms a landscape hour by hour. But on these distant worlds, change becomes deliberate. A slope of frost may remain almost identical for years. A shadow may define a basin with nearly ceremonial precision. A glacier of exotic ice may move, but at rates that belong more to patience than spectacle. Time is still present. It is simply no longer eager. That is one of the strangest gifts of the outer solar system. It makes time visible by slowing it, not stopping it, but stretching it until change becomes something you infer rather than easily see. This is especially powerful on worlds like Pluto, where active processes exist, but unfold under conditions so cold, so slow, and so unlike Earth that the result feels almost disciplined. Nitrogen ice can flow, haze can form, frost can migrate. A surface can renew itself, but all of it happens under a regime of distance that strips away any feeling of abundance. You are not watching life spill over. You are watching physics persist. That is a different beauty, a colder one, a more exact one. And colors matter there too, because the outer solar system is not monochrome. That is another misconception that falls apart when the data arrives. Pluto carries reddish-brown tones caused by complex hydrocarbon chemistry. Other distant bodies vary in brightness and redness and reflectivity. Even in the deep cold, surfaces hold identity. Not the lush identity of forests and oceans, but the chemical identity of ices. Radiation, sunlight weakened over immense distance, and ancient materials altered slowly over time. Content reference index equals 4. So if you stood on one of these worlds, You would not simply see white frost under a black sky. You might see subtle reds, dim golds, blue haze, black shadows so sharp they feel almost cut from the landscape, pale plains smooth as old bone, water ice mountains brighter or darker than the basins below them, a terrain not empty of character, but reserved in character, a landscape that reveals itself quietly. That is very different from the kind of beauty found on Jupiter or Saturn. Those worlds are theatrical. They announce themselves with storms, bands, rings. But the trans-Neptunian worlds do something else. They ask to be looked at more slowly. They reward patience. The longer you stay with them, the stranger they become. And perhaps nowhere is that strangeness clearer than in the way scale behaves. A mountain on Pluto may be made of water ice. A plane may be built from nitrogen. A moon like Charon may orbit not as a minor companion in the emotional sense, but as part of a double-world dance around a point in space between the two bodies. Everything about the region resists the first simple analogy. Even the sky resists it. On Pluto, the sun is still the sun, but made remote. On Sedna, it begins to feel almost like an exceptionally bright star. In the hypothetical Oort cloud, if one could stand on some icy object there, the sun might become little more than the brightest member of a sky no longer dominated by it at all. And now the question shifts. Because once the sun becomes that remote, what does belonging even mean? What does it mean for a world to still be in the solar system if its primary star has ceased to feel central in the everyday visual sense? This is where the outer system becomes psychologically profound. It teaches that connection can survive, even when intimacy is gone. A world can still orbit the sun, still belong to the solar system, and yet already inhabit a style of existence that feels half-translated into interstellar life. That is why landscapes beyond Neptune feel so calm and so unsettling. They are not cut off completely, but they are no longer held closely. They are still inside the family, but standing at the farthest edge of the room, where the warmth is weakest, where the voice of the center is faintest, where each world begins to keep more of its own silence. And if you stayed there long enough, you would probably begin to understand the landscape in a new way. Not as a failed version of Earth, not as a place waiting to become more habitable, but as a complete expression of distance, a world shaped by cold, faint light, thin or delicate atmosphere, slow surface chemistry, and time expanded beyond instinct. That completeness matters, because the outer solar system is not beautiful by approximation. It is beautiful on its own terms. On Pluto, that means a world of plains and haze and impossible ice geology. On Eris, a darker, colder remoteness. On Sedna, a reddish body under a sun that has become almost symbolic. On unnamed smaller worlds, perhaps nothing but frost and silence and a sky that feels too large. And still, all of them are real. That is the most important emotional anchor of this part. Real worlds, not just orbital solutions, not abstract remnants. Places. Places with horizons. Places with surface textures. Places where the sun still arrives, but differently. Places where silence is not empty, but structured by distance. And perhaps that is what the outer solar system does best. It teaches us that remoteness is not the same as absence, that a landscape can remain meaningful even when almost all warmth has left the scene, that a sky can still be beautiful even when the star at its center no longer feels near. In the final part, we will pull back again, from the surface, from the light, from the silence, and ask the biggest question of all. What do these distant worlds do to our idea of the solar system itself? Because once you have seen Pluto, Sedna, the detached objects, the fading authority of the sun, and the long, cold gradient beyond Neptune, the old map is no longer enough. And the edge of the solar system becomes not a line, but a philosophy of distance. And now, we come to the final question. Not what Pluto is made of, not how strange Sedna's orbit is, not how thin the sunlight becomes, or how far the Kuiper belt reaches, but what all of this does to the meaning of the solar system itself. Because once you have traveled beyond Neptune, once you have seen dwarf planets become real places, once you have felt the sun shrink into a distant authority, once you have followed objects so slow and so remote that a year no longer feels like a human concept, the old map does not survive unchanged. And perhaps that is the quiet achievement of these worlds. They do not simply give us more objects to memorize. They force us to imagine home differently. Most people inherit a solar system that feels compact. A bright center, a sequence of worlds, a tidy arrangement. The inner planets, the gas giants, Neptune, and then the edge. It is a satisfying picture, easy to remember, easy to draw, easy to feel. But the real solar system is less like a row of labeled objects, and more like a long, fading gradient, a system that thins, loosens, scatters, a system whose influence grows more delicate, more abstract, more widely distributed, the farther outward you go. That may be the deepest lesson of everything beyond Neptune. The solar system does not end in one gesture. It softens, it stretches, it becomes less certain. Not because science fails there, but because reality becomes more layered than the first diagram ever suggested. That is a very important difference. We often confuse uncertainty with weakness, as if a place that is harder to summarize must be less real. But the opposite is often true. The farther we go in science, the more the world resists the easy version of itself, and the outer solar system is one of the clearest examples. At first, it looks like a region where the known map runs out, but when we actually stay with it, it becomes one of the richest places in the whole story. Pluto changes the old ending. Eris changes the categories. Haumea changes the shapes. Sedna changes the timescale. The detached objects change the architecture, and the hypothetical Oort cloud changes the emotional size of the sun's domain. All of this from a region many people once imagined as almost empty. That reversal matters, because it teaches us something larger than astronomy. That distance does not necessarily simplify. Sometimes it reveals hidden structure. Sometimes the places we assume are least important turn out to be the ones that expose how incomplete our first understanding was. That is exactly why this outer region belongs here. Not only because it is beautiful, it is. Not only because it is cold and quiet, it is. But because it lives at the exact meeting point of hidden worlds and strange science. And that has been our promise from the beginning. To take ideas that seem distant, abstract, or almost invisible, and make them feel like places. Places with atmosphere, with geometry, with time, with silence, with consequences. Places the mind can enter. Because that is what these worlds become once you stay with them long enough. They stop being labels. They stop being the edge. They become experiences. Not experiences in the dramatic sense, not storms and impacts and noise. Something slower. A dwarf planet under a sun that no longer feels near. A horizon of nitrogen ice. A blue haze at twilight. A double world turning around a center in empty space. A reddish body moving through an orbit so long that history itself feels brief beside it. A distant population of icy objects, holding clues about migration, encounters, and the lost youth of the solar system. These are not footnotes. They are changes in perspective. And perhaps that is the true meaning of crossing beyond Neptune. You stop thinking of the solar system as a finished arrangement, and start thinking of it as a memory field, an old gravitational story, still written across bodies of ice and stone, a story with survivors, a story with fragments, a story with remote witnesses. That phrase matters. Remote witnesses. Because many of the worlds beyond Neptune seem to carry evidence, more quietly than the planets closer to the sun. The inner solar system has been heated, reshaped, collided, reworked. Its surfaces are dramatic. Its histories can be violent and visible. But in the far cold, some kinds of change happen more slowly. Some older records survive. Some clues remain sealed in orbits, in chemistry, in preserved surface materials. The region beyond Neptune is not only distant, it is archival. And there is something moving about that. The idea that the outer darkness is not blank, but preserving. Not merely cold, but remembering. Not simply the place where the planets stop mattering, but the place where deep planetary memory survives. If you let that settle for a moment, the whole system changes character. The sun is no longer only a lamp at the center. It becomes the beginning of a gradient of belonging. Closest to it, worlds are governed strongly, then more gently, then more distantly, then almost symbolically. And still, the tie remains. That may be the most psychologically strange part of all. A world can remain inside the solar system while already feeling half-translated into interstellar space. Still bound, but not close. Still connected, but not intimate. Still inside the family, but standing in a room so large, the warmth of the center barely reaches it. That is not a failure of the solar system. It is one of its most beautiful truths, that systems can remain systems, even when their edges become thin, even when their members grow scattered, even when relationship survives only through long gravity and immense patience. There is something almost human in that idea. Not because planets are like us, they are not, but because we understand, in our own way, what it means for connection to persist across distance, for influence to remain, even after nearness is gone, for belonging to become abstract without fully disappearing. And perhaps that is why these outer worlds feel so haunting. They are scientific objects, but they also press on some deep emotional structure. A sun still present, but no longer warm. A year still real, but too long to feel. An orbit still binding, but stretched almost to loneliness. A world still part of home, but living at the threshold of elsewhere. That kind of idea lingers. It lingers because it is not loud. The outer solar system does not force itself on the imagination the way Saturn's rings do, or Jupiter's storms. It enters more slowly. At first it feels simple, then remote, then strange, then quietly profound. And once that happens, the old map begins to look almost childish. Not wrong exactly, just incomplete. A first draft, a useful sketch, but no longer enough. That is not something to regret. It is something to love, because science is most alive, not when the picture stays small and tidy, but when the picture grows more truthful, when a clean border turns into a gradient, when a lonely final planet turns into a family of hidden worlds, when a static system turns into a history of migration, detachment, preservation, and unanswered structure. That is a better cosmos. Not easier, but better. A cosmos with depth. A cosmos that continues past the point where we once thought it ended. A cosmos willing to surprise us, quietly, again and again. If you return now to the beginning of this journey, to the old simple thought that beyond Neptune there is not much to see, that thought should feel impossible now, because now you know the outer darkness is crowded with icy bodies, dwarf planets, stretched orbits, thin atmospheres, slow chemistry, shared centers of rotation, buried history, and long unanswered questions. You know that Pluto is not a lonely punctuation mark, but the first clear sign that the edge of the solar system had been misunderstood. You know that Eris did not merely complicate a list. It exposed a problem in how we define worlds. You know that Haumea is not just one more distant body, but evidence that even shape can become strange out there. You know that Sedna does not simply orbit far away. It alters time itself, at least in the human imagination. And you know that the hypothetical Oort cloud, whether we picture it clearly or not, forces the solar system to become something vaster, softer at the edge, and more interstellar in feeling. That is a lot for one quiet region to do. And perhaps that is exactly why it belongs to sleep. Because sleep is one of the few states in which the mind can accept scale without fighting it, can accept slowness without impatience, can accept hiddenness without demanding immediate clarity. The worlds beyond Neptune are not built for hurry. They are built for duration, for patient looking, for the kind of imagination that does not need everything at once. That is why they fit this channel so naturally. They reward calm attention. They unfold in layers. They become more beautiful the longer you remain with them. Not because they become warmer. They do not. Not because they become easier. They do not. But because they become more complete. And completion is different from simplicity. A distant, icy world is not simple just because it is cold. A stretched orbit is not simple just because it is quiet. A region is not simple just because it lies in darkness. Sometimes darkness is where complexity survives best. Sometimes the cold preserves what heat would have erased. Sometimes the outer edge of a thing is where its deepest structure becomes visible. That may be the final scientific feeling of everything beyond Neptune, not the end, the reveal, the place where the solar system stops performing its neat version of itself and begins to show its age, its memory, its looseness, its hidden populations, its unfinished questions. And perhaps that is also the final emotional feeling. Not exile, not emptiness, but distance with structure, silence with history, cold with meaning. A kingdom of scattered ice, still held, still real, still moving around the sun, even when the sun no longer feels like a daily presence. If you imagine now, one last time, Pluto beneath its thin blue haze, Charon turning with it, Eris in the deep outer dark, Haumea stretched by its own speed, Sedna moving through a year longer than civilization, and beyond them, perhaps millions upon millions more icy bodies, older than language, fainter than easy thought. Then the solar system no longer looks like a classroom diagram. It looks like what it has always been, a layered architecture of light and cold, a family with a bright center and a very quiet far edge, a structure that does not stop neatly, but fades outward into mystery. And that may be the most beautiful ending of all. Not a border, a thinning, not a wall, a gradient, not a last world, a field of hidden ones. So tonight, as you drift towards sleep, keep that farther map in mind, the giant planets behind you, the sun smaller now, the warmth falling away, and ahead, a kingdom of distant ice, real worlds, slow worlds, worlds that asked us to redraw the solar system simply by continuing to exist where we once assumed almost nothing did. This is gentle science, hidden worlds and strange science, told softly for sleep. Thank you for traveling beyond Neptune with me. Good night.